Let us talk about this problem. We are given two unsorted arrays. We need to find out their intersection. And the intersecting elements we need to print in the same order as they appear in the first array. For example, if our first array is 10, 15, 20, 25, 30, 50 and the second array is this, you can notice that the common elements are 15 and 30. And we are supposed to print 15 first because 15 appears first in the first array. Then we are supposed to print 30. So our output is 15, 30. Now if you see this example, the common element is 20. So we print 20. In this example, all the elements are common, 10, 20, 30, 30, 20, 10. But we need to print them in the same order as they appear in the first array. So our output is 10, 20, 30. Now please pause this video and try to write down a function that takes two arrays as input and prints the common elements in the same order as they appear in the first array. A naive solution to solve this problem would be simply traverse through the first array elements, and for every element of the first array search it in the second array. If it is also present in the second array, then print it, right? That's what the naive solution is. So please pause this video and write the code for naive solution first. Let us first talk about a naive solution to solve the problem. See, in both the naive solution and the efficient solution, we are going to assume that all the elements in both the arrays are distinct. We are going to write our solutions under this assumption. So the idea of naive solution, as we discussed earlier, what we do, we traverse through every element of the first array. There are 3 elements in this example and 2 elements in this example. We are going to traverse through all these 3 elements. And for every element, we are going to search it in array B, right? So AI we are going to search in array B, and if AI matches with BJ, we set a flag equal to true. And flag is initially false. And as soon as we find a match, we break the loop, right? When we come out of the loop, this loop, we check if the flag is true for AI. If flag is true for AI, it means AI was matching some BJ, right? That means AI is common in both A and B arrays. So we print AI, then we print a space. See, the code that I have written here is kind of pseudo code, matches both with C++ and Java. In Java, you don't need to pass lengths of the arrays and arguments. You can get the lengths using a.length and b.length. Also, the print syntax in C++, you need to use cout, AI, and then spaces, right? And in Java, you need to use system.out.print, right, to print the array element and the space. So this is pseudocode matching and very close to both C++ and Java. So let's do a dry run of this code. For I equal to 0, when you run, you search it B array by running a loop for B array. It does match with this element. So we print 10 on the screen and we print a space after 10, right? Now we run for I equal to 1. When you run for I equal to 1, 20 is not present in the second array. We run through the second array, we do not find it. So we simply ignore this element. We are going to print the element only when the flag is true. So flag remains false because it does not match. Now we run for this 30. 30 is found in the second array. So flag becomes true. We print 30 on the screen. Now what is the time complexity of the solution? We are running a loop that runs m times and then another loop that runs big O of n time. Why am I saying big O of n? Because it doesn't always run n times, right? As soon as you find a match, you come out of the loop. So m into big O of n is big O of m into n. That's the time complexity of the solution. Now please pause this video and try to think of a solution that works in big O of m plus n time. You may again assume that all the elements in both the arrays are distinct. Let's now talk about idea for the efficient solution. Let's say we have these two arrays and you must have guessed that we are going to use hashing to solve the problem. Now a question for you, the first thing that you will do is you will create an empty hash table, right? Now which array elements you will insert into the hash table? Array A elements or array B elements, and then which array you will traverse. See, if I put array A elements into the hash table and then traverse through the B and check if the element is present in the hash table or not, I'll get the elements in the order as they appear in array B. But what I want is, I want the elements as they appear in array A. So what I'll do, I'll create an empty hash table first, right? Unordered set in C++ and hash set in Java. Then I'll traverse through all the elements of array B and I'll put them in the hash table. So hash table is going to have 30 and 20. Now what I'll do is I'll traverse through all the elements of array A for every element I'll check if it is there in the hash table or not. So 10 is there, I'll print 10 on the screen. 20 is there, no, I'll not print it. 30 is there, I'll print it. So that's how I'll get the output as 30, 20. Now what is the time complexity of it? See, inserting the elements of array B, this is size n and this is size m. This is going to take big O of n time, right? Or you can say theta n, because every element has to be inserted one by one. And then then you are going to traverse through array A, right? And then you are going to check if every element is present in hash or not. So checking is considered constant operation. And then you are going to print the elements which are present there. So it's going to take theta m time. So overall time complexity is going to be theta m plus n. Now you have enough idea. Please pause this video and write the complete code either in C++ or in Java. Here is complete implementation. Here we have C++ code and here we have Java code. So first we are creating an unordered set in C++, right? We are creating this unordered set using all elements of array B. We have discussed such syntax in count distinct elements in array video, right? And then we are traversing through array A, and for every element of array A, we are checking if it is present in the unordered set or not. Same thing we are doing in Java. We are first creating a hash set, and then we are inserting all the elements of array B into the hash set. See, these three lines are equivalent to this line of C++ code. We have shortcut in Java also, but for that shortcut we are supposed to have an integer array, right? Not an int array. So that's why I have written three lines of code. I am assuming we have int array input. So we are creating an empty hash set first, then we are inserting all the elements of array B, right? So that's how we create a hash set in Java, and this is how we create an unordered set in C++. Now we traverse through the array A, right? And contains function tells us whether AI is present in the set or not. If it is present, then we print it, right? The same thing we are doing here. We are checking if it is present in the unordered set. If it is present, then we are printing it. Because whatever elements are present in array B also, those elements of array B are supposed to be printed. And why are we doing this way? Because we want to maintain the order according to array A elements. So let's say we have 10, 20, 30 in A, and B we have 30, 10. So we created a hash set or unordered set, we inserted all the elements, and after step 1 we got the set as 30, 10. Now we traverse through array A, right? This is the set step 2 here, and what are we doing here? We are traversing from I equal to 0, 10 is present in the set, we print 10, then 20, I equal to 1, 20 not present, so we ignore it, I equal to 2, 30 present, so we print it, right? So we get the output as 10, 30 on the screen. What is the time complexity of it? See, this part is clearly theta n, right? We are inserting n elements of array B into the unordered set or hash set. So this part is theta n in Java, this is theta n in C++. And this part is clearly theta m, right? We are traversing through every element of array A and we are looking into the hash table, right? So this is theta m. So overall time complexity is theta m plus n. What is auxiliary space? We are creating a hash table and we are inserting n elements of an array. So auxiliary space is clearly theta n.